Welcome to the 6-3 Part 1 video on solving systems using elimination. Our objective: I can solve systems by adding or subtracting to eliminate a variable. Systems of equations can be solved in more than one way. We already know graphing and substitution. However, when a system has variables in the same position, so x's come first or y's come first, or if they're in the same location on the same side of the equal sign, and they have either the same coefficients, or I'm going to put a little caveat here about having opposite coefficients, the system is most likely best solved using the elimination method. Now, to be best solved might be totally subjective, but you might think of that as most efficiently or easiestly solved using elimination. Remember that any system can be solved reliably using graphing, substitution, or elimination. It's all about the accuracy of your tools. So if you're graphing calculator over a hand-drawn graph, for substitution, the ease of solving for a variable and then using algebra, and elimination is what we're exploring here. But all of them are valid methodologies. So what is the elimination method? Well, elimination method has 3 steps. The first one is we need to eliminate one variable, and this is why it's called the elimination method. And this step might have sub-steps where you might need to rearrange to get the variables in the same location, and you might need to scale up one or both of your equations. And then the actual step of eliminating will be to add or subtract the equations and their like terms. Once we have that done, we'll get a new equation with only a single variable. And this will be a combination of the 2 equations that made up the system. Once we have a single variable equation, we can then solve for that variable. And then finally, we can plug it back in or substitute it back in to find the other variable. So the elimination method requires you to know how to substitute back in, so it has to be taught after the substitution method. You'll see in this picture, steps 1 and step 2 are already done. So 2x plus 3y equals 20, negative 2x plus y equals 4. You can tell that the x's and the y's are vertically above each other. They're in the same location. These are both in standard form. And your constants are on the other side of the equal sign. We then add them. Negative 2x plus positive 2x is 0x. And 3y plus 1y is 4y. 20 plus 4 is 24. 0 plus 4y equals 24 is a 1-variable 2-step equation. Subtract 0 from both sides, divide by 4, you get y equals 6. So that's step 1 and step 2 on a very easy example. Once you do this, you take y and plug it back into either of the original equations, blue or purple, and now that is a 1-variable equation, and you'd use it to solve for x. So let's look at a very simple example where we're adding equations. We'll only add on this slide. So let's say you had an equation or a system like 2x plus 5y equals 17 and 6x minus 5y equals negative 9. Neither of these would be great to graph, and neither of them are particularly easy to work with on substitution. So instead, let's eliminate. You'll notice that the x's are lined up, the y's are lined up, and the constants are lined up, so no rearrangement is needed. And we see that if I add or subtract right here, 2x and 6x aren't going to cancel each other out. But the 5y and the negative 5y would cancel each other out if we added them. So let's add them vertically. 2x plus 6x is 8x, and 5y plus negative 5y is 0y, and 17 plus negative 9 is positive 8. 0y is just 0, so we really have the equation 8x equals 8. Divide by 8 on both sides, you get x is equal to 1. From here, we can plug it into either of the original 2 equations. If you plugged it into the 2x plus 5y equals 17, you get 2 times 1 plus 5y equals 17, so 2 plus 5y equals 17. Subtract 2, divide by 5, y equals 3. If you plugged it into the other equation, 6x minus 5y equals negative 9, you get 6 times 1 minus 5y equals negative 9. 6 minus 5y equals negative 9. Subtract 6, and you get negative 5y equals negative 15. And divide by that negative 5, get y is equal to positive 3. So remember, a system is where 2 lines cross in the xy coordinate plane. So your solution here is 1, 3. Let's do another one. Negative 6y plus 5x equals negative 32, and 6y plus 3x equals 48. Again, x's and y's are lined up. This is kind of standard form, but not exactly. And so let's eliminate. Adding won't eliminate the x's because I'll have 8x. Subtracting won't eliminate the x's because then I'd have negative 2x. But if we add, we'd get the y's canceling each other out. So negative 6y plus 6y is 0y. 5x plus 3x equals 8x. And negative 32 plus 48 is equal to 16. 0y is just 0, so this is 8x equals 16. Divided by 8, x is equal to 2. We can plug it in to either of those two original equations. So negative 6y plus 5x equals negative 32. Plug in 2 for x. 5 times 2 is 10. And so negative 6y plus 10 equals negative 32. Subtract the 10 from both sides. Divide by negative 6. You get y equals 7. I'll show you for the last time that it works in both equations. So 6y plus 3x equals 48. Plug in 2 for x. So 3 times 2. And then you get 6. 6y plus 6 equals 48. Subtract 6. 6y equals 42. Divide by 6. Y equals 7. Again, we have to write our answer as an ordered pair. So we get 2, 7. Now let's look at subtracting equations. And I'm going to put a little asterisk by here because some algebra courses don't teach subtracting. And we'll talk about that in a second. But subtracting is the inverse of addition. They're the opposite sides of the same coin. So subtracting is a valid method. Let's say a theater club sells a total of 101 tickets to its first play. Student ticket costs $1. Adult ticket costs $2.50. Total ticket sales are $164. How many student tickets were sold? So let's go ahead and label your variables because nothing's given to us. So let's say X is the number of student tickets sold and Y is the number of adult tickets sold. From here, we're going to have to go ahead and set up our system. The easy one to set up is a total of 101 tickets are sold. So the number of student tickets, X, plus the number of adult tickets, Y, is 101. The harder part is the cost. Student tickets cost $1. Adult tickets cost $2.50. So to figure out the value purchased of student tickets, it would be the cost of the ticket times the number of tickets. So 1x. And for the adult tickets, it'd be the number of adult tickets times 250, so 2.5y. Altogether, that total will sum to 164. So 1x plus 2.5y equals 164. Now, if you add here, nothing's going to happen. X plus 1x is 2x, and 1y plus 2.5y gives us 3.5y. So instead, let's subtract. Now, on the previous slide, drawing out the line and putting the addition sign seemed like a little bit of an extra step that maybe wasn't necessarily needed. But I highly suggest that you do it because when you subtract, it's in a good visual representation on what you're doing so you don't mistakenly combine things incorrectly. 1x minus 1x is 0x's. Y minus 2.5y is negative 1.5y. And 101 minus 164 is negative 63. Having that line and that negative there helps you realize that it's 1y minus 2.5y and 101 minus 164. It's very easy to make this mistake if you don't have that visual representation to remember that you're subtracting the top equation and the bottom equation, and the bottom equation is being subtracted from the top equation. So it is important because it's easy to mix up signs. 0x plus negative 1.5y equals negative 63. 0x is just 0, so it's really negative 1.5y equals negative 63. And divide by negative 1.5, you get y equals 42. We can plug it back in. I'm going to choose to plug it into the x plus y equation. You could do the x plus 2.5y and you get the same answer. But if y is equal to 42, plug in 42 for y, subtract 42 from both sides, x equals 59. You can double check to make sure that this works by plugging in 59 for x and 42 for y. 59 plus 42 is 101, and 1 times 59 plus 2.5 times 42 gives us 164. So we know we got it correct. So now before we move on to the next part, we need to make sure we have some basic understanding that we can use to help us moving forward. When we eliminate, what we're really doing is looking for a combination of adding or subtracting where the coefficients will end up being 0. We want to add the coefficients if they're opposites, so like 5 and negative 5, and we want to subtract them if their coefficients are the same, so like 2 and 2, or negative 10 and negative 10. The sum or the difference of the coefficients has to be 0. The 0 is what makes the variable eliminate, because then it has a coefficient of 0, which means that it itself is 0. We can use the multiplication property of equality to multiply each side of an equation to get a new equation that's equivalent to the original. So, for example, let's say you had a plus b equals c. If you multiply both sides by d, you would get d times the quantity a plus b equals d times c. If you distribute that d, you get dA plus dB equals dC. So all we did was we multiplied d to both sides and then distributed as needed. So a plus b equals c is the exact same line as dA plus dB equals dC. They are the same line. They lie on top of each other. And so they are equivalent and will have, therefore, the same points of value that could be used in a system. Since this is true, you can eliminate a variable by adding or subtracting if you first multiply an equation by an appropriate number, some scaled up or scaled down numerical value. You can then prove that the result is the same simply by substituting the values into the original equations to show that the equations are true. Let's look at an example like this. So let's say you had negative 2x plus 15y equals negative 32 and 7x minus 5y equals 17. Right now, if we add or subtract, neither the x's nor the y's would go away. We'd have no coefficients of 0. Looking at this, if I'm just going to multiply one equation, I see that the 5y in the second equation could be multiplied by 3 to get a negative 15y. And so let's do that. I could do this process twice and multiply to get rid of the x's. I could take that top equation, multiply by 7, and take the bottom equation, multiply by 2 if I wanted to get rid of my x's. But I can get to a coefficient of 15, negative 15, by just multiplying once. And so it saves me a step if I work a little bit more strategically. So let's scale up the entire thing by a multiple of 3. So you get 21x minus 15y equals 51. And that's the exact same equation as 7x minus 5y equals 17. They're equivalent. So let's rewrite our equations. Negative 2x plus 15y equals negative 32, original equation. And now this new one right underneath it where everything's lined up. 21x minus 15y equals 51. From here, the 15y and negative 15y are opposite, so we're going to add these equations. And negative 2x plus 21x gives us 19x. 15y plus negative 15y equals 0y. And negative 32 plus 51 equals 19. 0y is 0, 19x equals 19 then. Divide by 19, x is equal to 1. From here, you should only plug it into the original two equations, either negative 2x plus 15y equals negative 32 or 7x minus 5y equals 17. I'm going to choose the 7x minus 5y equals 17 just because it looks easier. Plug in 1 for x, 7 minus 5y equals 17. Subtract 7, don't forget your negative with the 5y, so negative 5y equals 10, so y equals negative 2. Again, write your answer as an ordered pair. You get the point 1 comma negative 2. For your other equation, so another second example, we have negative 5x minus 2y equals 6 and 6y plus 3x equals 6. Looking at this, doesn't seem like anything will cancel out, even if I were to multiply one of the equations, until you pause and say, oh, the variable components, the terms, are not lined up. The first term in the first equation has the x come first and the y come second. The second equation has the y come first and the x come second. So let's rearrange them before we do anything. Maybe that will help. So I'll rearrange the bottom one, put the x's first, because then it's in standard form, but could have rearranged the top one. First one's going to stay the same, negative 5x minus 2y equals 6. Bottom one's going to change to 3x plus 6y equals 6. From here, again, nothing's going to add or subtract away, but we now see that if you take that top equation and multiply it by 3, you'll get a coefficient of negative 6 for the y, which is what we're looking for. Again, I could have multiplied the top equation by 3 and the bottom equation by 5 to get coefficients of 15 and negative 15 for the x's, but let's solve it in only one multiplication step. So let's take that top one, multiply it by 3, and we're going to get negative 15x minus 6y equals 18. And let's bring down that 3x plus 6y equals 6. I really like to rewrite them and line everything up. From here, we have opposite coefficients for y, so we're going to add them. And we get negative 12x plus 0y equals 24. 0y is 0, so negative 12x equals 24. Divide by negative 12, you get x is equal to negative 2. From here, let's plug it into one of the original two equations, not something we made. So let's use that negative 5x minus 2y equals 6. Plug in negative 2 for x. Negative 5 times negative 2 is positive 10. 10 minus 2y equals 6. Negative 2y is equal to negative 4 when we subtract 10 on both sides. Don't forget your negative with the 2y. Divide by negative 2, y equals 2. Giving us the ordered pair negative 2, comma 2. So here's a quick and handy flowchart to help you understand how to do elimination, because those 3 steps are just 3 steps, but there's a lot built into them. So number one thing you should do is ask, can I eliminate a variable by adding or subtracting the given equations? If yes, go ahead and add them. You want to add when the coefficients are opposites. 5, negative 5, 10, negative 10, or whatever. You want to subtract when the coefficients are the same number. And this is easy to remember because whenever, first grade, whenever you subtract a number from itself, you always get 0. 5 minus 5 is 0. 20 minus 20 is 0. So you want to subtract when the coefficients are the same number. Students get a lot of this mixed up because of negatives. Negative 18 minus negative 18 is still 0. When you subtract a number from itself, you always get 0. So when the coefficients are the same, subtract. If you cannot eliminate a variable just by adding or subtracting the given equations, multiply one of the equations and then add or subtract. If that produces a pair of coefficients that are either the same or opposites, go ahead and add or subtract. If not, what you're going to have to do is multiply both equations, and usually it's a different number for both equations. And then once your coefficients are either the same or opposites, then you are going to add or subtract them. We'll look at that last step where you multiply both of them in the next video.